Okay, so today we are going to talk about composition of forces, okay? You all know the second Newton law that the force is mass multiplied by acceleration. The question is, you know that there is plenty of forces such as weight, normal force, friction force, and usually we don't have just a force acting on a body, but several forces. For example, I have made here some examples. Imagine you have a ball and you kick it, you will have a force, the one you exert by kicking, but also you may have the friction force, of course the weight, we always have the weight, the normal force. So on this body, on this ball, we have four forces acting, or even in a book on a table we have at least two forces acting, the weight and the normal force. Or here I have painted a pendulum where we have the force we do to move the pendulum, the tension for the weight. So we usually have more than one force. So which of all these forces will we put in this equation? Well, none of these forces. In fact, we are going to put something that we call the resultant force. What is the resultant force or the net force? It's the force we imagine that will make the same effect than all these forces acting together on our body. Okay? And how are we going to calculate it? That is a problem, because as you see, in a force, it is not only important the magnitude of the force, the number of newtons, but the direction. We always represent the forces as vectors because we have to be very aware about the direction in which that force is exerted, okay? So what we are going to learn is how to calculate this resultant force depending on the direction of that force, okay? The first case we are going to study is the easiest one, is the one about forces that are in the same direction, okay? If we have forces in the same direction, imagine we are pushing this box with two forces that are acting in the same direction, okay? The resultant force will be a force bigger than these two forces, okay? This resultant force is the sum up, the addition of these two forces. And the direction is, of course, if I push this box with two different forces in that direction, the net force, a force that we imagine that is making the same effect than these two forces together, will act in that direction, okay? So the net force is a force in that direction whose magnitude is the sum up of these two forces. So the resultant force is a force of 7 newtons in the right direction, okay? This is the resultant force, 7 newtons. Okay, so if they are in the same direction, we have a resultant force in the same direction that is obtained the magnitude summing up both forces. What about forces that act in opposite direction? Imagine, I think it was one of the examples on your last worksheet, you have someone pushing a box in this direction and another person pushing in the opposite direction. Where will this box move? It will move to the direction in which the biggest force is exerted, okay? But it will move not as fast as it will move if we were just exerting this one force, because we are also exerting another force in the opposite direction, okay? That will make the effect of this force weaker, okay? So the resultant force of these two forces acting on that body is a force in the direction of the biggest one, Okay, that is the resultant force, and whose magnitude is obtained by resting these two forces. Okay, so in this case, as we have a force of 4 Newton and another of 3 Newtons, the resultant force is a force of 1 Newton in the right direction. Okay, the direction of the biggest force, the one of 4 Newton, and the magnitude is obtained by resting these two forces. Okay, so what about forces that act in different direction, but not in the opposite direction, in any direction, as the ones we have in that example? Okay, to draw the force that is acting on that body, what we are going to do is what we call the parallelogram method. Okay, what does this parallelogram method consist on? It is very easy. What we are going to do is drawing a parallelogram. How? We are going to draw a parallel line to the first vector in the final part of the other vector, okay? And now this line parallel to this vector in the final part of this vector. And now another parallel line to the other vector, to the blue one in this case, in the final part of the other vector. Okay, now we have here a parallelogram. Okay, the diagonal of this parallelogram is the resultant force. Okay, how we draw the diagonal of this parallelogram? From the origin of the vectors to the other edge of the parallelogram, we have the resultant force. That is the resultant force. Okay, let's see another examples, because I know this is not that easy to be understood and you need to practice more. Okay, for example, here we have another example. So, okay, here in this example we have a force of 4 newtons to the right and another force of 3 newtons, vertical force. Okay, so how would we do the parallelogram method? We draw a line parallel to this red vector in the final part of the other vector, okay? And a line parallel to this blue vector here, where the other vector, the red one, ends. Then we draw the diagonal of this parallelogram, in this case of this rectangle. We draw it diagonal and we obtain this vector. This vector is the resultant force. If we had a box in which we have a box like this one here, okay? Imagine we have this box and I am exerting a force to the right and another vertical force. This box would move this way, as if I were exerting a force from this point, okay? The effect of this box is the same than doing these two forces at the same time. The box doesn't move neither in that direction nor in this. It moves like in this diagonal. That is what the resultant force is. Making these two forces together is the same than making only this one. Okay, that is why that is the resultant force. Quickly, let's see other examples. In this case, we have this force of 4 newtons and this other of 3 newtons. So we draw a parallel line to this vector of 4 newton in the final part of the other vector. So this is the parallel line. And a parallel line to this one here, okay? We obtain a parallelogram, and the diagonal of this parallelogram is the resultant force. That force, we imagine that would make the same effect on the body than these two forces together. Okay, another example, the same. Parallel line to this here, parallel line to this vector here, we obtain a rectangle. The diagonal is the resultant force. What about this one? the same. A parallel line to this here, a parallel line to this here, the diagonal is the resultant force. Okay, so in the previous cases, in the one of the same direction and also in the one of the opposite direction, we were able, by resting or by adding, to calculate the magnitude of the vector. What about these cases? We can draw the force, but are we going to be able to calculate the magnitude of this vector or not? Well, we are not always going to be able to do that. We are only going to be able to do that in the cases in which the two initial vectors are perpendicular, okay? Are forming a right angle. If we have a right angle, an angle of 90 degrees, we are going to be able to calculate the magnitude of that resultant force. In other cases, like in this one, where the initial vector don't form an angle of 90 degrees, we are not going to be able to calculate the magnitude of this resultant vector. Let's see how are we going to do that. How are we going to calculate the magnitude of the resultant vector? What we are going to do is using the Pythagoras theorem, okay? You know it from mathematics, okay? In this case, we have these two vectors, this of 4 newtons and this of 3 newtons, forming 90 degrees. So they are perpendicular. So that is why we are going to be able to calculate the magnitude of that resultant force. Okay, first of all, you are going to draw it. Parallel line to this vector in this, in the end of the other vector, parallel line to the red vector in the end of the blue vector, and the diagonal of this rectangle is the resultant force. This one is the resultant force. Okay, as you can see, when you paint this rectangle, you obtain two right triangles. Two right triangles. That means dos triángulos rectángulos, okay? Because they have a right angle, an angle of 90 degrees. Okay, if you remember from mathematics class, we can only use the Pythagoras theorem when we have right rectangles, triángulos rectángulos. Solo se puede usar el teorema de Pitágoras cuando tenemos triángulos rectángulos. Cuidado, ¿ok? What does the Pythagoras theorem says? That summing up the square of the two legs, os recuerdo esto en español porque estáis acostumbrados a la clase de matemáticas en español. The two legs son los dos catetos. Los dos catetos, the two legs, are the sides of the triangle that form the right angle. Los dos catetos son los lados del triángulo que forman el ángulo rectángulo, el ángulo de 90 grados, ¿vale? La suma de los cuadrados de los catetos, que son estos dos lados de aquí, es igual al cuadrado de la hipotenusa. Summing up the square of the two legs, we obtain the square of the hypotenuse, okay? So, in this case, you know the value of this leg, okay? It's 4 newtons. But you don't know the value of this other leg. Well, in fact, you may know, because if you see this side, this leg, measured exactly the same than this, okay? Can you see that the length of this side, this length, is exactly the same than this length? Okay, so this is also 3 newtons. So you know the value of the two legs, okay? 4 newtons and 3 newtons. And what you want to know is the value of the resultant force. And the resultant force is the hypotenuse, okay? That is why the resultant force, the square of the resultant force equals one leg to the second power plus the other leg to the second power, okay? So the square of the resultant force is 2 times 4 plus 2 times 3, okay? So 16 plus 9, 25. The square of the resultant force is 25. That means that the resultant force is 5, okay? So only in the cases that we have perpendicular forces, using the Pythagoras theorem, you are going to be able to calculate the value of the resultant force. Okay? So next, if you remember at the beginning, I put these pictures in which you have, in this case, 4 forces, in this case 2, and in this case 3 forces. Okay, but I have only explained you how to calculate the resultant force of 2 forces. What happens if we have more than 2 forces? Okay, that is no problem. What we are going to do, if we have more than 2 forces, 3, like in this case, 3 or even 4, we are going to calculate the resultant force of 2 of these forces, okay? And then we can forget about these 2 forces and just take the resultant force and calculate the resultant force with another force. Well, I know it sounds very strange, so I am going to explain it with some examples. I think it is going to be easier for you to understand what I mean, okay? For example, in this case, we have 3 forces. Okay, something I always recommend you, if you have 3, 4, whatever number of forces, always start with those that have the same direction or the opposite direction, because those, the 2 first cases we have studied, are the easiest cases to calculate the resultant force. You just need to sum up or rest the values, okay? So in this case, you will always start with this force of 2 newtons and this other of 3 newtons, because they are in opposite direction, okay? So to calculate the resultant force of these 2 forces, you just need to rest the value of these 2 forces, okay? As they are in opposite direction, the resultant force of these 2 forces would be a force of 1 newton to the right, okay? 1 newton. Okay, this force of 1 newton, that is the resultant force of these 2, is the same that making these 2 forces together, okay? So I can forget about these 2 forces because this one of 1 newton is the same than these 2 other forces together, okay? So next, you need to calculate the resultant force of this and this, okay? So parallelogram method, we paint a parallel line to this one in this point, and a parallel line to this vector here at the end of the other vector, okay? Now you have the parallelogram, and you can paint the diagonal of this parallelogram, that is the resultant force, okay? This only force is the same that making these 3 forces together, okay? In this case, as these 2 forces are parallel, we could calculate the value of this resultant force by using the Pythagoras theorem. One leg plus the square of the other leg, okay? So this is 5, so the resultant force is this. So 2.23. newtons, okay, in that direction. Okay, let's see this other case. We have 3 forces. This is very easy. We are always going to start with those that are in the same or in opposite directions. In this case, we have these 2 forces of 2 newtons in opposite directions. So we would rest them. 2 minus 2 is 0. So these 2 forces together is the same than doing nothing at all. So the resultant force in this case is a force to the right of 3 newtons, okay? Because the effect of these 2 forces together is null. So we just have the effect of this force of 3 newtons. What about this case? We have 2 forces in the same direction, okay? Let's imagine this is 4 newtons also, okay? We have 2 forces of in the same direction. So to obtain the resultant of these 2, we sum up both, and we obtain a force of 6 newtons to the right. So making a force of 6 newtons to the right would be the same that making these 2 forces together, okay? So we can just take this force of 6 newton and forget about these 2. Then we make the resultant of this force of 6 newtons and this other of 4 newtons by the parallelogram method, okay? And we obtain this force, that is the resultant force, okay? So, and you could calculate the value, the magnitude of this force if you want. Okay, last case, but not least. In this case, instead of 3 forces, we have 4 forces. Okay, so we will calculate the resultant of 2 of these forces, those that are in opposite direction. So in this case, we have one force of 1 newton to the right. Okay, I calculate it by resting 3 minus 2 and the direction, the one of the biggest one. So with this force of 1 newton, I can forget about these 2. Then the resultant of these 2 forces is another force of 1 newton. Okay, so we can forget about this and this, because making this force of 1 newton is the same that making these 2 forces together. Now we are going to calculate the resultant of this force of 1 newton and this other, okay, by the parallelogram method. And we obtain this force. This force I am painting now, I am drawing now in black, making just this force, whose magnitude you could calculate with the Pythagoras theorem, is the same that making these 4 forces together. Okay, that is what the resultant force means. Okay, so now you have some exercises to practice all these things and all the things about the Newton's laws and the different kind of forces you have. Okay, that is the best way to get to understand all these things, by practicing. Okay, you can go back in this video all the times you need. Okay, and if you have any question, you can always write to my email rocco.blanco@educa.madrid.org. Bye.